Hello everybody and welcome back. Today's video is a different one. Today I want to take a look at this machine here and I want to find out if it is possible to convert one of these indoor ACs with a single hose into one with two hoses. The single hose unit works very simple. It takes the air from the room and it puts it through its condenser and it exhales it to the outside. It pulls air from the room and vents it outside. So it sucks air from other rooms into the same room, assuming that the air that is going to come from those rooms is not as hot as the air outside or as hot as the air that it's pumping out, because that is really hot because it uses it for cooling. Now, the downside is, of course, that you take air that is already cooler than the outside air and you vent it outside. This makes these things pretty ineffective. There is a video by Technology Connections that explains this in great detail, and if you haven't watched it, go watch it. So I want to take time and build everything that we need so we can take this unit that I bought at a local flea market. It's broken. It's not as badly broken as the one that I had 2 years ago, but it just doesn't turn off when it's supposed to, and it only works at certain settings, but I don't care about that. I just want a cool room that I can work in, and I don't really want to pull hot air into other rooms because this thing just creates a vacuum in the room that I'm working in. So what I went ahead and I did was I made not one of these, but two of them, and they can go into the same window or door, and they're reasonably spaced, so I can make sure that I don't take in all the air that I've just expelled, which is one of the risks when you have a two hose unit. And I also went ahead and I modified this one to have connectors for outlet and inlet. Now, you might want to pause the video right now and write in the comments what you think is going to happen. Is this going to increase the efficiency? Is this going to keep it from venting cold air to the outside? Or what's going to happen? The result is quite interesting and I didn't expect it, but it's different. Let's just leave it at that right now. And I'll show you what I did, and I'll show you the result, and maybe we can move forward from there and get it to be different. So I printed an adapter for the backside that would accept a second hose. It has the same size as the outlet, and the spacing with the grill back here is about the same spacing as I have here. Of course, the air coming out here will be pressurized, so it will be easier to exhale than it is to get in here. I'm accepting this right now. For the grill that was around here, I just taped that off with duct tape and made sure that this is, well, somewhat tight. I didn't want to overdo it because I didn't want to break the unit, and I was more or less just interested in, will this increase the efficiency? Because if I take the air from the outside and use it for cooling and vent it back to the outside, then I shouldn't have that much of a heating effect from the outside inside the room that I'm in. And that's exactly what I expected, but I didn't get that. And the reason for that is quite interesting. I'll show you. Now, as you can easily make out, the hole or the area for the intake is a lot smaller than what it was before when I attached the hose. It just has so much more space to pull in air into the device, and that air is later expelled here, right to the outside. I was thinking that maybe this had to do with the fact that this was low pressure air and this is compressed high pressure air. But it should still have somehow worked similarly. And I would have expected to have the same effect still be alive for the cooling, because I did not expect a large temperature change from intake to exhaust or something like that. And a cooling unit like this should be capable of operating across a wide range of temperatures, just because it has enough coolant in there. But I found something else that severely degraded the performance when I had both hoses attached. And remember, there are devices that can be bought that have two hoses. I was assuming, and I know it's wrong now, that a device that has two hoses simply has this plastic part here exchanged for one that has an adapter for the hose. But that would make these two devices be like at the same price. And for some reason, devices with two hoses come at a 10 to 15% premium. And well, I couldn't explain why that would happen. Now we need to go a little bit deeper into the AC unit itself. What you see here is the compressor. What you see here is the condenser. Down here is a little pump that is used to slosh around condensate, water from the evaporator, and just make the whole process a little bit more efficient. So the air coming in here is not only used for the condenser, but also to cool the compressor. That's perfectly fine. The thing that becomes apparent though, when you look at the edges here and into the device, there is actually no insulation from the high power, high pressure side to the low pressure side, apart from the outlet. So what's happening if I attach the hose here is it does take in air through the hose with the air coming from the outside, but it does also take in air from everywhere else on the device. So basically, every little hole and opening in the device suddenly becomes an air inlet. And unfortunately, that includes the cold air outlet. So what I noticed happening when I attached the hose coming from the outside to the back where it takes in air is that the air output from the unit suddenly dropped. So it was actually taking air that it was supposed to blow out, cold air, and it was using it to feed this inlet. And as far as I can tell, and I'm going to dig deeper into this machine, what is missing is an insulation layer that basically makes sure that the air intake is insulated from the rest of the machine. So when it sucks in air, it can only do through this hole. So when I have a second hose connecting it to the outside, I can be sure that the air is taken from there and not from the room. Now, looking at the back of here, this totally explains it, why the whole thing was kind of a failure. The whole frame sits at a distance to the outside. So you have the base, you have the compressor, you have your heat exchangers, but it draws in the air through one of the heat exchangers, but it can take the air from anywhere. It doesn't actually have to take it right from the back. It can take it from the bottom. It can take it from the top. It can even take it from the vent at the top, or very close to that. So by masking the back of here and just attaching the hose in the back of here, I've favored it taking air from here, because it will be trying to equalize the vacuum in the room. But that didn't work as good as I was expecting it, because there was still quite some pressure drop in the system, and it would just start taking air from everywhere else. It would actually be taking air away from the heat exchanger at the top, because it could just suck the air away from that. It can do the same at the exhaust port. And well, it seems that this unit is just not built for being insulated in a way where the chamber that leads to the exhaust fan is separated from the rest of the machine. And that seems to be the difference that makes for the price difference. So a machine that is built for two hoses is essentially completely different on the inside. Now, it would be interesting if I could seal off this chamber to the right here, up to the point where it would be taking most of the air from the outside, and then I could rely on the effect of the cooling and the air going through there to cool the rest of the system. But it's pretty clear that it is using the air from around here to cool all the components. So there's a big motor in here. The heat exchanger gets very warm, of course. So does the compressor. And there's probably some electronics in there too that do produce some heat. So it seems to explain that, yes, it works. So it is equalizing the pressure from the air that I push out through here, that goes out through the window fitting, and it takes the air in from there, but it doesn't do it perfectly. Even more so, it then starts taking warm air that it just sucked in from the outside, and it is using that air to produce cold air for the room, ruining the efficiency of the unit. So what would actually would have to happen is the systems in themselves, the low pressure zone and the high pressure zone, would have to be completely separated and maybe even be insulated to each other. And there would have to be some sort of lining in here that makes sure that pressure cannot escape from one zone into the other, and by that we don't leak energy from one zone into the other. So what I was actually having as an effect was that the air coming out of the unit would be warmer than it was before I had the modification, but the room itself would hold the cold air slightly better. The whole efficiency of the unit did not really change, and looking at the way things are happening here, it absolutely makes sense, because I couldn't guarantee that I was using only outside air for the cooling process. I was also pulling in cold air from the room, and I was also taking away some of the air that was going through the vent that was supposed to have the cold air. So, and this experiment was basically just proof that it didn't work. What would have to happen is I would have to be able to really create a zone of low pressure and just have that zone be connected to the vent coming from the outside to make this thing be more efficient. It's really too bad. It really is. So I'll take it further apart. I just noticed there's a lot of screws missing in this unit, so it's probably been apart before. But let's see if it would be possible to, I don't know, use aluminum tape or some other sealant to seal off the different areas in here. Now here's actually an interesting look at the device. As you can see, there are hold downs for most of the wire parts, although they're not used, and there appear to be elevated surfaces that you could have some sort of insulation foam on, but they're not used at all. Same thing goes for the lower side. It would be very much possible to have some sort of insulation material on the bottom of the device going all around, basically shielding the inside from pulling in outside air. So then you would have the entire lower part being the low pressure area, the vent from the big fan being the high pressure area, and the second part of the low temperature heat exchanger, the evaporator, would be a zone of its own. It could be possible to insulate the device so that would be the case. Right now the insulation at the top and on the edges here, I can't turn this far enough, but you can see it here. There's no insulation here at all. So it would have been possible for some of the air that vented here to be pulled into the device right at the same instance when it was supposed to exit. And that is probably some part of what lowered the pressure on the cold side. So I'm actually not sure if it's feasible to close off the entire lower part of this and to make it somewhat airtight. It would be necessary to introduce some sort of high temp foil or something and really get this in here so this becomes one closed off cavity. So it would actually only be drawing in air from the outside vent. But it seems to be possible to improve on the insulation between the chambers. So it would maybe pull in a little bit of air from the underside through the ring at the bottom, but not influence the output of the cold side. Hard to say, but what this does show is that units that have two hoses must be constructed completely different on the inside, and that is probably the reason why they have such a premium price. Because this simple construction on the inside is just not made for a double hose device. This is pretty obviously as cheap and as simple as can be, and modifying it is not easy. Yeah, so that's what I learned. I learned that you can't just add a second hose to the device and expect it to have a much better performance, because the second hose just doesn't do exclusively what you think it would do. It still brings in hot air from the outside, and the hot air from the outside does get mixed with the air that you're trying to cool, and you're basically not cooling the room down as much as you would expect it to. But well, I thought this was interesting. Thank you for watching, and bye-bye. I'm going to try to put this back together now. Let's see how far I get. Let's see if we can get this thing. Should be a little bit better. Working better. Well, all right. I taped up all of the front side up to the point where it now is a completely separated chamber from the back where we need the air. I did not modify anything else there, but sorry about that. This thing now extends all the way to the part where we draw in the air. I added some high temperature insulation here because I didn't have anything better, but this stuff is really squishy, and it seals this cavity pretty well. Because there's a load of space over here. I added some foam material here that should seal up against the condenser, and that should probably give me the separation I want, so that all the air that is used for the condenser is now actually being pulled in through the back. I really hope that this works. Yeah, I'm going to try and put it together. maybe do some experimentation, see how much suction I get at the back. Make sure that I don't get any overheating in the front, but I don't think so, because it can actually pull the air past the compressor and past all the components that are in there really well, and this could work out. So I'll be putting it back together now, and let's see what happens. So it's back together. I did not lose any screws. These things are not meant to be taken apart and put back together, because I think I stripped out 2 or 3 threads. But apart from that, it's back together. I'm going to turn it on now, and I think I will be able to feel the difference in suction that I'm getting from this opening now, because it is now pretty much isolated from the rest of the machine. So it's not really a change to the machine itself, but the chamber that is taking in the air, which gets passed through the condenser, and the air that is then expelled out through the window, should now all be coming in through this opening, and very little through the others. There might still be some small holes in there, and I don't want to seal it up completely, because this air might be used for cooling components and stuff like that. But if I now use my second hose to pull air in from the outside, I should have a lot less leakage of cool air to the outside, because I now have a pretty much insulated airflow from air coming in from the outside and going back to the outside. I may lose some efficiency, because the air from the outside might be a lot warmer than the air that it's taking in from the inside. But since this is a compressor-based system, which is basically a heat pump, and it should have enough reserve of coolant to work around that. It's basically the way that heat pumps work. They don't really pump heat, but they take the coolant from the vapor state to the liquid state, and that just consumes energy. And that's the energy that the compressor brings in. And then there's a temperature change that causes the coolant to liquefy again, and once it gets to the evaporator and the pressure that it's at gets dropped, it evaporates, taking in energy from the ambient air, or basically from the surface of the cooler. And that the compressor is only working the phase change, and the two heat exchangers are basically one is basically taking the energy that was put in by the compressor, and it's taking care of that energy, and the other one is basically taking in the energy that is required for the coolant to evaporate again. So it's not really a heat pump. It is just a phase change mechanism that produces and requires energy. So it produces the energy and vents it to the outside. It requires energy and takes it from the room. It's really quite simple. I'm going to turn it on now, and let's see what happens. Nothing happens. Oh. All right. Yeah, it seems to be drawing in a lot more air, but there's also quite a lot of air coming out here. And yeah, I suppose I will just have to try it out. But as far as I can tell right now, it's still running fine. So I didn't interfere with anything electrically, and I didn't break it when I took it apart, which is a good thing. Okay, still not finished. So I put my extra baffle for holding the hose back on. I reapplied the duct tape around the openings that were still there, and when I now put my hand against the opening and hold it closed, I can actually starve out the fan. So this is almost completely airtight, which is exactly what I wanted. So now I'm really interested in test results regarding the air circulation in the room and the efficiency of the cooling.